we start by trying to find the equation of a linear function y equals f of x with the property that f of 2 equals 4 and the rate of change is 1/2. Okay, so people were pretty good about understanding that the 2 was an x value and the 4 was a y value. About half the class went ahead and plotted the point where x is 2 and y is 4, which is exactly what you want to do. Now, the other half pretty much, indicated this point on the x-axis, indicated this point on the y-axis, but for example, there was some confusion. People might have thought this was the y-intercept, or that this was one thing or another, and didn't realize what f of 2 equals 4 really tells you. It simply says that when x takes the value 2, y has to take the value 4. Meaning that if x takes the value 2, the y-coordinate has to be 4, so you have this point on the graph. Okay, so again, f of 2 equals 4 means that when x is 2, y is 4, we get this point. Now, the rate of change is 1/2. What does that mean? Well, people weren't real clear on that, so I said, well, let's just say xy is a point on the graph of this linear function. What does it mean for the rate of change to be 1/2? Now, this means the rate of change is 1/2 between any 2 points. So if xy is a point on the graph, then the rate of change from here to here has to be 1/2. Now, we identify the rate of change, and this is really the rate of change of y with respect to x. So kind of let that statement or that phrase echo in your brain, because it's going to become important when we try to model things with linear functions and later with functions that aren't linear. Okay, so if this point is on the graph, then a fundamental triangle between this point and this point is going to have a slope of 1/2. Okay? Now, I asked people to, sketch a point on the graph. And people said, okay, well, if you move some distance in the x direction, you're going to move half that far in the y direction. That was extremely insightful. That was a very good statement, and that's exactly what happens. So we can say that if you have some delta x here, then your delta y is going to be half of that. So that your rise, delta y, divided by your delta x is 1/2. Well, I'm going to approach it this way. Rate of change 1/2 means the change in y divided by the change in x is 1/2. Totally equivalent to what I just said here. This means then, if the change in y divided by the change in x is 1/2, then, well, if I multiply both sides by change in x, I get change in y equals 1/2 times change in x. So change in y is 1/2 of the change in x. Meaning the slope of your fundamental triangle then has to be 1/2. Well, here's our fundamental triangle between 2, 4, and xy, between our no point and our arbitrary point on the graph, our point xy somewhere on the graph of this function. The slope of this triangle has to be 1/2. Well, what can we say about the fundamental triangle with these 2 points? We can say that the rise is y minus 4, and about half the class immediately got that. Just came up and said, well, you're going to have y minus 4, you're going to have x minus 2, exactly. The change in y from 4 to y is y minus 4. The change in the x-coordinate from x equals 2 to point x is x minus 2. There's your rise, there's your run. So if you're familiar and literate with the fundamental triangle, it's very easy to write down these expressions. If you're not, then it's much harder, but that's something that was to be mastered during the very first week of class. Please understand, if you don't master things, then you're not able to use them later, okay? So you get rise here, run here. So your slope, of course, is rise divided by run, which is y minus 2 over x minus 2. But of course, we've already said that the rate of change is 1/2, which means that the slope is 1/2. So that the slope, y minus 4 over x minus 2, has to be equal to 1/2. Now, we want to solve this equation for y. And we found that, algebra was nearly but not quite up to the task of solving this equation for y. Now, there are easier things we can do when introducing linear functions, but eventually you have to be able to do the algebra. Your algebra has to be up to solving this equation for y. So that's what we focused on here. Once you have this idea, it comes down to this equation. You got to be able to solve this equation for y. And if you use a formula that you might have to memorize for the equation of a straight line under different circumstances, you still have to be able to do that equivalent algebra. So no matter how you approach this, you have to be able, your algebra has to be up to solving this equation for y. Okay, so here we go. We try to solve this equation for y. Okay, well, you should stop and solve that equation for y, and I'll go on in our next clip.